everyone, welcome to GemChem. Now today's video is on chain reaction, chemical kinetics part 11 video, and here we are going to deal with non-stationary chain reaction. Already 10 videos are uploaded in channel, you can watch it. I will give the link in the description box as well as the I button present above this video. And in the previous video we have already covered the stationary chain reaction. So all the derivations and all the concepts will be derived from that video only. So stay tuned. During the non-stationary reaction, we have already seen that this is a branched chain reaction, right? So since it is a branched chain reaction, we can expect that there will be the value of alpha would be greater than 1. And we have already seen in the previous video that the concentration of R dot, that is the reactive intermediate, had been obtained like this: K1 A concentration by minus K2 alpha minus 1 A concentration plus K3, and this K3 actually meant that it will be equals to Kw, that is due to the presence of collision with the walls, and Kg is due to the presence of gaseous phase. Already know that red is directly proportional to R dot, and here we can have the glance that K2 alpha minus 1 concentration of A becomes equal to Kw plus Kg when we see that alpha is greater than 1. So if denominator is 0, we have already seen that the concentration of R dot will be infinite. This reaction proceeds with such huge rate and leads to an explosion. So occurrence of explosion depends on first temperature, second is pressure, and 3 such limits of explosion is observed. Actually, main point which is the criteria for explosion is pressure. So depending on the pressure of the system, we can consider that there are 3 limits of explosion. How to develop the concept of explosion? So for that we are going to draw a graph. So first you are having 2 axes, one is reaction rate and another one you are going to have your pressure axis, and you are going to have 3 pressures, one is P1, one is P2 and the last one is P3, and the graph would look like somewhat this. First it will increase, then it will become a steady reaction. So this part is a steady reaction. Next what happens, again this is a steady reaction at P2, and on increasing further pressure it becomes a explosion part. So we are going to describe the whole graph here. This portion is our explosion limit. Remember, the third one which we will talk about is our thermal explosion taking place. So from here only you can see that at low pressure what happens is that this is our initial stage. So diffusion of R dot to the walls is easy and the destruction is very large, as a result of which collision with the walls is also large, and in this case you will have Kw much greater than Kg at the initial stage of pressure. So here denominator becomes positive. So as a result of which the reaction will proceed with a smooth rate. Now up to P1 there will be steady reaction. So you can write down P1 as the first explosion limit. P1 is first explosion limit. Now in this case what happens is that after first explosion limit Kg becomes much greater than Kw, and P2 is our second explosion limit. So as you are increasing the pressure, diffusion of R dot to the walls become difficult, as a result of which Kw decreases. why is it becoming difficult? If you apply more and more pressure, the gas molecules will become compressed in their structures. As a result, they cannot move, right? So Kw decreases much more rapidly than increase in Kg. At certain pressure, a situation will arrive when you are going to see that your K2 alpha minus 1 A equals to Kw plus Kg, that is your R dot is becoming infinite. And if you are still further increasing the pressure, as a result of which this Kg will become much greater than Kw. So Kw becomes less and less, Kg is very large, denominator is finite positive value, thus there is a thermal effect occurring. Radicals internally get destroyed, and increasing pressure causes the heat liberation and production rate becomes different. So temperature of the system goes on increasing and heat is liberated at each elementary step and can't escape from the system at same rate as it is being produced. So as a result of which we can observe the most exploited term, which is explosion. So what is required for explosion to occur? Increase the pressure to certain extent that there comes the thermal effect acting on it. As a result, Kg becomes more than Kw, and there is the last stage, which is non-stationary chain reaction. So one of the example of non-stationary reaction is reaction between the H2 and O2. It is an example of a no termination, only branching reaction. And in this case, reaction being exothermic, no heat can be dissipated, and temperature increase, reaction rate increase, heat increase. As a result, there is thermal explosion. So here ends the topic of your non-stationary chain reactions. In the next video, we are going to deal with basics of collision theory. Hope this was helpful. Thank you for watching.